Something strange just happened in our solar system, and scientists can't explain it. A massive interstellar object called 3I/ATLAS just passed near Mars, leaking alien chemistry no human has ever recorded. Its CO₂ levels? Off the charts, far beyond any comet ever observed. Was this a natural relic from another star, or something else entirely? Let's dive right in. It began quietly, July 1st, 2025. The Atlas telescope in Chile was scanning the skies when a small dot appeared in the Sagittarius constellation, faint but moving far too fast. Hours later, astronomers across the globe confirmed what seemed impossible. This object wasn't orbiting the sun, it was simply passing through. They called it 3I/ATLAS, the third interstellar visitor humanity had ever caught. The first was Oumuamua in 2017, the second was Borisov in 2019. Both changed how we viewed the universe, but Atlas was different, bigger, brighter, and moving faster than anything before. At first it looked like a comet, but the light patterns told another story. Its brightness didn't match its size. If Atlas were small, it was too bright. If it were large, it should have been seen long ago. Something was glowing from within, something the models couldn't explain. The early conclusion was cautious, possibly cometary. But as the data poured in, the tone shifted from curiosity to disbelief. NASA's Hubble telescope pointed toward Atlas on July 21st, 2025. At 446 million kilometers away, it caught an eerie teardrop-shaped glow, a coma of gas and dust surrounding a nucleus too small to resolve. The image was stunning but confusing. If the core was truly less than 1 kilometer wide, the sheer brightness made no sense. It was too active, too soon. At that distance from the sun, most comets remain quiet, frozen, lifeless. But Atlas was alive. So the James Webb Space Telescope stepped in, joining forces with SphereX. Between August 6th and 12th, their spectrometers revealed something groundbreaking. Atlas wasn't powered by water ice like normal comets. It was fueled by carbon dioxide, and in staggering amounts. The CO₂ to water ratio hit 7.6 to 1. The highest ever recorded. For comparison, even the most active comets in our system rarely exceed 1 to 1. That's when scientists realized this wasn't just another interstellar object. It was a chemical outlier, a relic of a completely different planetary system. Under the cold conditions of deep space, water freezes first, CO₂ much later. That means Atlas either formed closer to its parent star's CO₂ ice line, or it spent billions of years bombarded by cosmic radiation, stripping away water and leaving behind carbon dioxide. Either way, it carried the chemical memory of another world. Its surface had been etched by time itself. Spectral lines confirmed traces of nickel, cyanide, and carbonyl sulfide, identical to compounds found in comets from our own solar system. So, while its chemistry screamed alien, its ingredients whispered familiar. This paradox is what drove scientists crazy. How can something so foreign still share the same cosmic DNA as us? One theory proposed that the building blocks of comets are universal, that every star system uses the same ingredients, only arranged differently by temperature, gravity, and radiation. In other words, the recipe changes, but the pantry stays the same. That single idea reframed how astronomers viewed planetary formation, and it made Atlas more than a comet. It became a time capsule, a frozen story from another star. Then came October 3rd, 2025. Atlas was approaching Mars, closer than any interstellar object had ever been to a spacecraft. The European Space Agency's ExoMars Trace Gas Orbiter and Mars Express turned their cameras toward it. These weren't comet hunters. They were designed to study Mars' atmosphere. Yet engineers risked precious resources to capture this once-in-a-lifetime moment. Through 5-second exposures stacked over hours, they finally caught it. A single glowing dot drifting across the Martian sky. It looked simple, but it wasn't. That tiny smear of light represented a 7-billion-year-old traveler, born before our sun even existed. Analysis showed the coma stretched 680 kilometers wide, steady and symmetrical, just like the Hubble and Webb data months earlier. No eruptions, no fragmentation, no drama. Atlas was stable, ancient, and almost eerily calm. That stability told scientists one thing. This was no fragile ice ball. It was built to survive. And that raised the question no one wanted to ask. Could Atlas be artificial? Harvard astrophysicist Avi Loeb raised the argument first, not claiming proof of alien technology, but pointing out an anomaly. For an object releasing over 150 kilograms of gas per second, Atlas barely accelerated. The rocket effect from escaping gases should have pushed it slightly off its predicted path. But the deviation was tiny, less than 15 meters per second squared. That means it was unusually massive, at least 33 billion tons, maybe more. A comet that size shouldn't have gone undetected for so long, unless it entered our system from an angle no telescope was watching. Still, no geometric reflections or metallic spectra were found. Everything pointed to natural ice and dust, but even skeptics admitted it was too perfect. No comet had ever matched so closely with theoretical models of ancient galactic formation, yet contradicted so many known laws of interstellar probability. Coincidence? Possibly. But with odds like 1 in 500 for its trajectory alignment with our solar plane, some scientists weren't so sure. The real scientific gold, though, came from spectroscopy. ESA's NOMAD and SpyCam instruments aboard ExoMars are now processing isotope data, ratios of carbon-13 to carbon-12, oxygen-18 to oxygen-16, and deuterium to hydrogen. These are cosmic fingerprints, unique to each solar system. If Atlas's ratios differ from ours, it's the first direct proof that we've measured the chemistry of another star's planetary system. Not from light years away, but right here, in our own backyard. This is more than discovery. It's a bridge between worlds, and it shows the power of what's called adaptive astronomy, using existing spacecraft in new, unexpected ways. Instead of waiting decades to build a mission, humanity reacted in days. Mars orbiters became deep space observers overnight. That agility gave us the closest look ever at an interstellar object, something no dedicated probe could have achieved in time. But beyond the data, Atlas carries a deeper significance. Its age, estimated between 7 and 14 billion years, means it's older than the solar system itself. That suggests it may have formed around a metal-poor dying star in the Milky Way's thick disk, a region filled with ancient, slow-burning suns. Over time, gravitational nudges from passing stars flung it free. For billions of years, it wandered the galaxy, collecting radiation scars, surviving collisions, and drifting through interstellar voids until, finally, it crossed paths with us. That journey alone tells a story of resilience, not just of matter, but of time. At first glance, CO₂ might seem mundane, but in space science, it's a powerful clue. Carbon dioxide reveals how a planet or comet formed, what temperature range it lived in, what radiation shaped it, and what chemical reactions once defined its surface. So when Atlas showed an unprecedented CO₂ dominance, scientists realized they were looking at something untouched by our sun's heat, a chemical fossil of a world that never was. That ratio alone could redefine how we understand the birth of planets across the Milky Way. Because if carbon dioxide-rich comets are common in other systems, it means water-based worlds like Earth may be rarer than we think. And that, changes everything. Atlas didn't just give us data, it gave us perspective. It reminded us how tiny and recent we are. When this comet began its journey, our planet wasn't even dust. The sun didn't exist. Yet here we are, photographing its icy glow from Mars' orbit. For billions of years, it drifted alone, silent, ancient, and unseen. Then, for a few days in October 2025, it entered our field of view, and humanity caught it, just long enough to listen. As the comet continues outward toward Jupiter, questions remain. How did it survive unbroken for so long? Why does it resist acceleration despite massive outgassing? And how many more interstellar visitors are out there, waiting to be found? The Vera Rubin Observatory, now operational, might detect dozens more over the next decade. Each one could carry a different chemistry, a new message from another time. But 3I/Atlas will always be remembered as the first comet whose chemistry broke our models. The one that proved our understanding of the universe is still painfully incomplete. 3I/Atlas wasn't a sign of aliens. It wasn't a spacecraft. It was something far more powerful, proof that we are part of a much larger cosmic story, a frozen messenger from a forgotten star, carrying within its carbon dioxide and dust the ancient signature of another world. And for a few hours near Mars, humanity looked up and saw it passing by. In the end, 3I/Atlas reminds us how little we truly know about the universe, and how much more there is to discover. A comet older than our sun, carrying alien chemistry across billions of years, passing right through our cosmic backyard. It's proof that exploration never stops, and neither should our curiosity. If you value clear, science-based stories like this, don't forget to like this video, share your thoughts in the comments, and subscribe to Galactic Breaking News for more real discoveries shaping our understanding of space. Turn on the notification bell so you'll be the first to know when the next mystery from deep space breaks.